I'm the Geology Product Manager with LMKR. I am responsible for the discovery of geological applications, time and money by keeping all the geosteering active X section and smartSECTION and the new geosteering extension to smartSECTION, smartSTRAT. In this video, I will introduce you to Discovery smartSECTION with FrameBuilder, GeoGraphix next generation of geological interpretation application, and its horizontal well correlation and geosteering tool, smartSTRAT. smartSTRAT can save your unconventional asset teams time and money by keeping all the geosteering activity within the project database and currently active geomodel. We call this activity geomodeling while drilling. I will start this demonstration with a brief overview of smartSTRAT with FrameBuilder and explain how interpreting in smartSECTION creates a dynamic, accurate, and robust 3D model. I will be explaining the smartSTRAT extensions to the cross-section view of smartSECTION and demonstrate the horizontal well correlation process and workflow. After the well is correlated, I will use the 2D smartSTRAT model to update the project database and geomodel, display an on-the-fly, depth-converted, and scaled seismic backdrop, and draw a target line to generate the parameters the drilling engineers need to keep the well within the productive zone and on target. By some estimates, 80% of all new wells being drilled in North America are horizontal wells. These horizontal well drilling programs are often planned out months to years ahead of time. Because of this high rate of activity, staffs are strained to keep up with the drilling workload. Often these same staffs are also required to develop new plays, prospects, and drilling programs. Therefore, because of the cost of drilling and completing horizontal wells and limited staffs, efficient management of active projects and accurate geosteering of horizontal wells is a vital economic necessity. GeoGraphix features industry-leading technology on a central project database, mapping, and 3D visualization system for the successful development of today's resource plays. GeoGraphix offers an uninterrupted environment that streamlines critical geology, geophysics, petrophysics, and engineering workflows, which maximizes production and return on investment in both conventional and unconventional resource plays. Discovery smartSECTION is GeoGraphix next generation of geological interpretation. smartSECTION with FrameBuilder is a robust 3D geomodeling application that understands the relationships between conformable surfaces, surface intersections, and truncations to build sequence stratigraphic frameworks that are geologically correct. You are looking at the main map view in smartSECTION. The B surface displayed in the map view is being dynamically modeled from the well picks in the well-based database. The E surface is a deeper surface and is less well sampled than the A or B surfaces. By using FrameBuilder modeling tools, the E surface can be made to be conformable with the better modeled A and B surfaces. The Geosurface Modeling Properties dialog is used to load surfaces into the FrameBuilder geomodeling engine by selecting Formation in the Surfaces tab. Conformance relationships are defined in the Surface Constraints tab. The A surface is the best sampled and understood surface because it is the shallowest. The B surface is set to be conformable to the A surface, and the C, D, and E surfaces are conformable to the B surface. By turning on the Conformance tool, the E surface now conforms to the B surface but honors the E picks from the database. FrameBuilder now maintains this conformance relationship between all the modeled surfaces in the geomodel. Because smartSECTION is already a robust well correlation and geomodeling application, all that was needed to make smartSECTION a geosteering tool was to add the features to the projected cross-section view to enable horizontal well correlation. Therefore, smartSTRAT is simply a functional extension to the cross-section view in smartSECTION. The vertical section cross-section shown here is laid out along the horizontal reach of the well being drilled. The drilling well is projected orthogonally into the plane of the projected cross-section. The point of intersection becomes the zero vertical section origin for measuring horizontal distance from the well position. Engineers call this kind of projected cross-section a vertical section. smartSTRAT mode is activated by clicking on the smartSTRAT tool in the toolbar. smartSTRAT adds two new panels to the vertical section view and a 2D dip line in the cross-section view to represent the geometry of the dip fault model. The vertical panel displays the type log and the TVT of the LWD log curve. The horizontal panel displays the LWD curve in red and a predicted curve in blue based upon the geometry of the 2D dip fault model, the wellbore, and the type log being used. The smartSTRAT Options dialog is launched by clicking on the Options icon. The Options dialog features several tabs that control the selected model, the dip fault model geometry, line of section layout, display options, and target line inventory. On the main tab, the user selects the well to correlate, the active surface to model, and the current frame builder or 2D dip surface model. Multiple what-if correlation scenarios can be interpreted to help the user converge on the best possible correlation. The Tie Points tab exposes the controls for building the dip fault 2D model and the type log options. By default, smartSTRAT uses the local drilling well's log curve to generate a type log in the vertical panel. This is desirable because this type log is the closest to the near portion of the horizontal wellbore. However, if necessary, an offset type log can be easily substituted. Notice the red LWD curve's symmetry about the landing point of the wellbore. This symmetry is generated because of the downward to upward transition of the stratigraphy. By using the dip slider to match the blue predicted curve to the red LWD curve, the dip of the 2D model at the intersection of the wellbore is determined. A tie point is placed with a right mouse click at the correlation position of the LWD and predicted curve to create the first dip segment record. Notice that the type log in the vertical panel turn green, indicating that it is now a dip-corrected TVT type log. Notice the pattern of the red LWD curve. The smiles and frown patterns indicate possible stratigraphic traversals. A trial dip segment can be placed in the middle of one of these patterns to subdivide the wellbore into more manageable pieces. By zooming into the vertical panel, the blue TVT of the LWD curve can be manipulated to adjust the dip to match the type log in the vertical panel and the LWD and predicted curves in the horizontal panel. In a like manner, the correlation process proceeds down the borehole until the current TD is reached. Tie points can also be placed with a double click to streamline the workflow. Copies of the type log can be hung from the active surface along the cross-section view to aid in updating the geomodel. Now that the well is correlated in the 2D dip model, the 3D project geomodel needs to be updated. The 3D geomodel surfaces are turned on in the cross-section view from the Surfaces tab. These surfaces are dynamically modeled in Frame Builder from well pics in the database. Notice that the B surface from the 3D geomodel does not match the magenta 2D dip surface model. Therefore, the geomodel needs to be updated. Using the picking tools in smartSECTION, interwell points are placed along the 2D dip surface to tie the active 3D B surface to it. Frame Builder maintains the conformance between the 3D surfaces as the interwell points are picked. The 3D B surface in the main map view is updated automatically with the interwell points. If a 3D seismic survey is interpreted in SeisVision, a dynamic depth-converted seismic backdrop can be displayed in the cross-section view to look ahead of the borehole to reveal possible faults or other geohazards. Notice that if the well trajectory is not corrected, the wellbore will soon be out of zone. A target line tool generates the drilling parameters necessary for the drilling engineers to put into their computers to get the well back on target. The new drilling parameters can be copied to the clipboard and pasted into an email to send to the drillers in the field. smartSTRAT is portable. A copy of the project or project AOI can be loaded on a laptop to be used in the field. From the field, the last geosteering model can be emailed back to the office to update the master project with the latest interpretation. The benefits of geomodeling while drilling with smartSTRAT are an order of magnitude increase in productivity because all correlations and modeling are done in the project geomodel. There is no data I/O. smartSTRAT creates the most reliable horizontal well correlation possible because you can use multiple accurate TVT type logs for the correlations. smartSTRAT can detect faults, stratigraphic variations, and geohazards in front of the borehole because of the available seismic backdrop display on the vertical section view. smartSTRAT creates the most accurate geosteering and field modeling possible because of the benefits of combining the ease of correlating in a 2D vertical section with the robustness of a full 3D geomodel. LMKR GeoGraphix offers an uninterrupted interpretation environment which maximizes productivity. LMKR GeoGraphix enables streamlined mapping, geophysics, geology, well planning, geosteering, and visualization in one tool set, minimizing the cost and time to learn multiple tools. LMKR GeoGraphix is deployed in many of the largest shale plays and has a proven success record in accelerating the exploration and production of today's resource plays.